Alright guys, welcome back for day 2 of exponentials. Day 2 of exponentials. We're going to talk about growth and decay in terms of word problems today, and actually more like compounding interest. I know, crazy, right? It's actually ties to the real world. This is crazy. Alright, let's talk about exponential growth. We know that exponential growth increases over time. Okay, so the first blank is going to be increases at a consistent rate over time. A, in this case right here, A is going to be your initial amount. R, that puppy right there, is going to be the rate. And that's usually seen as a decimal, so don't freak out. And then T is going to be your time. T is going to be your time. You'll see this as like annually, quarterly, something like that. Alright, so looking at number 1. Number 1 says Adam made an original investment of $2,000. The value of this investment has increased 7.5% each year. Write an exponential function to model this situation, then find the value of the investment after 10 years. Alright, so we're going to list out A, R, and T. A is the initial amount. So it said he made an initial investment of $2,000, so that's going to be A. R, which is your rate, is going to be this as a decimal. Now, 7.5%, in order to make that a decimal, you need to move this 2 decimal places. So it's going to be 0.075. And then T is your time, which in this case it said after 10 years. Alright, so all you're going to do is you're going to plug this into this formula. Right? So f of t, or we could say y, it's the same exact thing, is equal to A, which we know in this case is 2,000, times 1 plus R, which is 0.075, raised to the 10th power. Okay, so now what am I going to do? I'm going to do what's in the parentheses first. So y equals 2,000, and then 1.075, I add those two together, and that's raised to the 10th power. Now, all I got to do is take this, raise it to the 10th, multiply by 20. by 2,000. Okay, I'm going to put that in my calculator, and I get y equals 4122.063. So it says on the graph of this function, the y-intercept would be, all we're doing is we're looking where x is 0. So that's going to be at 0, 2,000. Now, what is that? That's going to be the initial amount. Remember back to the last class, we talked about the y-intercept is the initial value, right? I said those are the exact same thing. So the initial amount that he invested was $2,000. Okay, after 10 years, he has $4,122. Going on to number 2. Okay, number 2 says the population of a town in 2001 was 14,512. The town has increased its population by 3% each year. Write an exponential function to model this situation to find the population of the town in 2020. Alright, so once again, we need to list out A, R, and T. A is the initial value, R is the rate, T is the time. Again, this is the decimal of 3%. 3% decimal places here, you need to move it 2 places. So it's going to be 0.03 as a decimal form. That's going to be your rate. Your initial value is 14,512. Now, the time, it says it was in 2001, and it wants to know the population in 2020. Okay, so I need to know the difference in years between those 2 years, right? So from 2001 to 2020, 19 years have elapsed. So that is your time, 19. Now, to write my equation, I'm going to get y equals, again, I'm plugging into this formula, so A we know is 14,512. 1 plus the rate, which is 0.03, and raised to the 19th power. Again, what we're going to do is we're going to do what's in the parentheses first, so I get y equals 14,512, and then 1 0.03 raised to the 19. We're going to take this, raise it to the 19th, multiply by that number, and you get y equals 25,447. We just figured out that in the year 2020, that town will have 25,447 people. Again, it says of the graph of this function, what is the initial value, right? So when x is 0, what's the y-intercept? The initial value is going to be 0, 14,512. Again, the initial value. So where is it starting at? Where is it starting at? All right, going on to number 3. Sorry. Going on to number 3. It says the company's sales for its first year were blah, 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 blah. So that's the A, right? The initial value. So 175,620. We know that the rate is going to be this as a decimal. So 1.5, and I'm going to move it 2 decimal places to the left. So 0.015. And then T is the time after 10 years. Again, all we're going to do is we're going to plug into our formula, right? So y equals 1,750,620, and then 1 plus 0.015 raised to the 10th power. Again, we're going to take care of what's in the parentheses first. So y equals 175,620, and then 1.015. Take this, raise it to the 10th power, multiply by that number, and you get y equals 203,814.179. So we just figured out that's the total sales after 10 years. It says in the exponential equation y equals a times b raised to the x, what is the value of b with a growth rate of 1.5? So I get 1.015. What is the value of b with a growth rate of 1.5%? Okay, growth rate is raised to the x power. Now this is greater than 1. That's just a note for the growth, right? Because we're talking about exponential growth, it should be greater than 1. The b is greater than 1 for it to be an exponential growth. If it was between 0 and 1, it would be an exponential decay. Hint, hint. Moving on to the next page. The difference between the first page and this page is that now I have a minus sign here. Okay, nothing changes. The value is going to decrease over time, but A is still going to be your initial value or initial amount. R is still going to be your rate. T is still going to be your time. So number 4, the original value is 5,000, so A equals 5,000. The value has decreased by 2.25%, so once again we want to make that a decimal, so 2.25. We're going to move it 2 decimal places to the left, so R is equal to 0.0225 T after 3 years. All we're doing is we're plugging into this formula, right? So Y equals 5,000, 1 minus 0.0225 raised to the 3rd power. Again, we're going to take care of what's in the parentheses first. So I get y equals 5,000. And then 1 minus 0.0225 is 0.9775. And that's raised to the 3rd power. Once again, we're going to take this, raise it to the 3rd power, multiply by 5,000, and we get y equals 4670.04. It says of the graph of this function, the y-intercept would be, again, we want the initial value. And it says in the exponential equation, y equals a times b raised to the x power. What's the value of b with the decay rate of 2.25%? Okay, so we get 0.9775, right? That's what we get right here, 0.9775. Okay, that's where that came from. Now, once again, this is between 0 and 1. Okay, between 0 and 1, and that we know is a decay function. Looking at number 5. Number 5 says Bo bought a new car for $42,000. All right, so A is going to be $42,000 in 2018. The car depreciates in value approximately 6.5. Okay, so that's going to be the rate of 0.065 each year. What will the car be worth in 2022? Okay, so what's the difference between these 2 years, right? I need to figure out 2022 minus 2018. That's going to be a difference of 4 years. So that's T. That's the time elapsed. I'm plugging into my formula, which is right up here. A, which we know is 42,000. And then 1 minus 0.065. And again, it's a decay problem because it says it depreciates in value, and that's raised to the 4th power. Now again, I'm taking care of what's in the parentheses first, so y equals 42,000. And then 1 minus 0.065 is 0.935. That's raised to the 4th power. So we get y equals $32,099.312. Okay, so now obviously if I was to write that in money form, that's going to be $32,099 and then 31 cents in money form. You can't have 0.312 in money form. Okay, well, we went with the initial value. The initial value was 0, 42,000. In the exponential equation, y equals a times b raised to the x. What's the value of b? The decay rate of 6.5%. Okay, well, we found that. It's 0.935. And again, we know that is a decay function. Last one, number 6. A restaurant in town bought a new Viking commercial convection oven for $32,000. So again, we know that that's the initial value. It depreciates, so we know that we're using the minus formula in value 1.5%, so the rate is going to be equal to 0.0125. And I wanted to know what's going to be worth 8 years after it's purchased, so T is going to be 8. Okay, what we're doing is plugging in, so 32,000, 1 minus 0.0125 raised to the 8th power. And again, I do what's in the parentheses first. Sorry, can't see. Do what's in the parentheses first, so 0.9875. That's raised to the 8th. I get y equals 28,936.55. Again, we're in money form, so I need 2 decimal places. The initial value, obviously, we know is going to be 0, 32,000. And then it has a decay rate of 0.9875. There it is right there, so 0.9875. And again, we know that is between 0 and 1. That's why it is a decay function. Bada bing, bada boom.